Hello students, welcome to Philobytes. In this video, we are going to start a new chapter, that is chapter 8, which is Symbolic Logic. Here we are going to learn about the value of special symbols. In this video, I have discussed only conjunction, disjunction and negation. We will learn how to determine the truth value of compound statements with the help of truth tables, and after this video, you shall find downloadable answers, the link of which will be provided in the description box. So let's begin. Now, previously in the 5th, 6th and 7th chapters of Introduction to Logic, we have discussed Aristotelian or classical logic. But chapter 8 marks the beginning of modern or symbolic or mathematical logic. Now, this modern logic does not build on the system of syllogisms, which we had discussed in the previous chapters. It does not involve the analysis of categorical propositions. To discriminate valid from invalid arguments, modern logic begins by identifying the fundamental logical connectives on which deductive arguments depend. Now, what are these logical connectives? Let's find out. Now, symbolic logic requires an artificial symbolic language. In natural languages, some peculiarities make exact logical analysis difficult because words may be vague or equivocal. Sometimes the constructions of the arguments may be ambiguous, and metaphors and idioms may confuse or mislead, and sometimes emotional appeals may distract, and so forth. That is, what I'm trying to say is natural languages have certain constraints. To overcome these constraints, an artificial symbolic language has been introduced in symbolic logic. So these difficulties can be largely overcome with an artificial language in which logical relations can be formulated precisely. The most fundamental elements of this modern symbolic language will be introduced in this chapter. So it is the logical relations, the logical connectives, which are fundamental in this artificial symbolic language. So what is the most important thing to understand in symbolic logic? Obviously, the symbols and the logical links which connect those symbols. So symbols greatly facilitate our thinking about the arguments. With symbols, we can perform almost mechanically with the eye some logical operations that might otherwise demand great effort. The modern symbolism with which deduction is analyzed differs greatly from the classical. The relations of classes of things are not as central for modern logicians as they were for Aristotle and his followers. Instead, logicians, that is, modern logicians, look now to the internal structure of the propositions and arguments and to the logical links, which are not many, very few in number actually, and they are critical in all deductive arguments. Okay, so before we get into the symbols and the logical connectives or links, let us first understand what are simple and compound statements. A simple statement is that which does not contain any other statement as a component. For example, Charlie is neat is a simple statement. On the other hand, if I say Charlie is neat and Charlie is sweet, that will be a compound statement because it contains another statement as a component. So it is actually a conjunction of two simple statements, and each of these simple statements is considered to be a component of this compound statement. So what is a component? A part of a compound statement that is itself a statement and is of such a nature that if replaced in the larger statement by another statement, the result will be meaningful. So, Charlie is neat and Charlie is sweet is a compound statement. Charlie is neat is one simple statement. Charlie is sweet is another simple statement. Together, they are making this compound statement. So now let's understand the connectives, that is the logical connectives. The first one is known as conjunction. Conjunction is a truth functional connective meaning and it is symbolized by a dot. A statement of the form P and Q, that is P dot Q, you are going to read it as P and Q, is true if and only if P is true and Q is true, which means that if, see, P and Q, these are the symbolical forms of the simple statements. Let us take the example we just now discussed. Charlie is sweet and Charlie is neat. So if the first simple statement, that is Charlie is neat, is taken as P and Charlie is sweet, the second simple statement is taken as Q, and they are compounded together with the help of a conjunction, that is and, then we can write it like this: P dot Q. Then what will be the truth value of P dot Q? P dot Q as a whole will be true if and only if both P and Q are true. P and Q. Remember, we are considering the truth value of the entire compound statement, not just P or Q. We are considering the truth value of P and Q, P dot Q. Okay, so if only P is true, then the entire compound statement will not be true. If only Q is true, then also the truth value of the full compound statement will not be true. Only when both P and Q are true, then we can say that P and Q is true. So there are several types of compound statements, each requiring its logical notation. The first type of compound statement that we are discussing right now is conjunction. We can form the conjunction of two statements by placing the word and between them, and it is symbolized as a dot. And the two simple two or more, there can be more also. So the simple statements which make that compound statement, they are called conjuncts. In this case, that is P dot Q, we find there are two conjuncts. One is P, the other is Q. There can be more. There can be P and Q and R, like that. Thus, the compound statement Charlie is neat and Charlie is sweet is a conjunction whose first conjunct is Charlie is neat and whose second conjunct is Charlie is sweet. So the table you see in front of you is the truth table for conjunction. The compound statement, which in this case is a conjunction, is P dot Q, that is the third column. And what are the conjuncts? The conjuncts are P, first column, and Q, the second column. Now, every statement is either true or false. That is, every statement has a truth value, where the truth value of a true statement is true and the truth value of a false statement is false. This means do not think that when you're asked to write about the truth value of a statement, they're asking you to write whether it's just true. No, truth value means true or false. Okay, so the truth value of the conjunction of two statements is determined wholly and entirely by the truth values of its conjuncts. I told you previously that when we are trying to find out the truth value of the compound statement P dot Q, we have to consider the truth values of its conjuncts, that is P and Q. So P can be true and Q can be true, or P can be true and Q can be false, or P can be false and Q can be true. Finally, P can be false and also Q can be false. These are the only four options as far as truth and falsity of P and Q are concerned. So in such a situation, if it is only when both P and Q, these two conjuncts, that is both the conjuncts are true, only then the conjunction, that is the compound statement P dot Q will be true. In all other cases, if any one of the conjuncts is false, the compound statement, that is P dot Q, will also be false. So that is why it is said, if both its conjuncts are true, the conjunction is true. Otherwise, it is false. So just remember, true makes true as far as conjunction is concerned. Also remember that when you are making this truth table, there is a way in which you have to write. You see, because there are four possibilities here, that is four rows, you have to always start with true. So because it is four, you can divide it into two parts. So true, false, false, that is the first column. In the second column, you go alternately. True, false, like that. If you just write like that in this manner, you will see that you have addressed all the four possible combinations of true and false. This is the way, this is actually uh, the way you're supposed to make the truth table. The second truth functional connective is that of negation. The negation or contradictory or denial of a statement in English is often formed by the insertion of a not in front of the original statement. So it is customary to use the symbol curl, or it is also called a tilde, to form the negation of a statement. Thus, where M symbolizes the statements all humans are mortal, if this statement, that is all humans are mortal, if this is symbolized as capital M and a curl is put before that capital M, it will read as not all humans are mortals. Or you can also read it as some humans are not mortal. Or you can also read it as it is false that all humans are mortals, and also it is not the case that all humans are mortal. Basically, you are denying, negating the statement M, which is all humans are mortal. Now, some logicians treat the curl as another connective, but since it does not really connect two or more units, like we saw in the case of conjuncts forming the conjunction, it is sufficient to note that it operates reversing truth value on a single unit and thus may be referred to as an operator. It is an operator. It operates. How does it operate? It operates by reversing the truth value. If it is false, a negation sign will make it true. If it is true, the negation sign will make it false. And it is technically, you may not call it a connective because it is not really connecting two simple statements. So the truth table for negation will be a very simple one, because it is not really connecting two or more units. It is basically one unit. So the number of options as far as truth and falsity will only be true. That is, if P is true, not P will be false. And if P is false, not P will be true. That's it. So the negation of any true statement is false and the negation of any false statement is true. This fact can be presented very simply and clearly by means of the truth table that you see in front of you. The third truth functional connective which we are discussing in this video is that of disjunction. Disjunction is a truth functional connective which means or. The components which are connecting to form the disjunction, which is the compound statement, the simple statements in this case are called the disjuncts. The disjunction of two statements is formed in English by inserting the word or between them. The two component statements so combined are called disjuncts, which means alternatives. So now we find the truth table for disjunction in front of us. The compound statement is P will Q. It is a small v. It is called a wedge. It means either P or Q. The disjuncts which form this compound statement are P and Q. These are the disjuncts. The disjunction or alternation of two statements is formed in English by inserting the word or between them. The two component statements are called disjuncts or alternatives. Now this word or is ambiguous, having two related but distinguishable meanings. You will see that in some cases the two disjuncts can be true at the same time. For example, you can say either Ram will come or Sham will come. There is no contradiction in this compound statement. Both can be true. Right. So in this case, the word or is weak and inclusive. So this is the non-exclusive, or it is a weak disjunction. It is called a weak disjunction. But you will see that in other cases, both the disjuncts cannot be true at the same time. For example, if I say either he is dead or he is alive. So here both cannot be true. One has to be false. So in both these cases, we see that either one of the disjunct is true or the other is false, or both of them are true, like we saw in the weak and inclusive situation. So, pertaining to these differences, that is weak disjunction and strong disjunction, we have the first three rows, that is both P and Q are true. Any one of them, that is either P is true, Q is false, or P is false and Q is true. That is, any one of them is true. In all the three situations, the compound statement P well Q is true. It is only when both the disjuncts are false, it is only then that the compound statement P well Q will also be false. So just like I had asked you to remember that in conjunction, true true makes true. In the case of disjunction, just remember false false makes false. That's it. If you remember this much, you will be able to do the truth tables very easily. Let us now also discuss the punctuation that we use in symbolic logic. This is not a truth functional connective, but it is very crucial to understand and interpret them correctly. Otherwise, we cannot validly infer the truth value of the arguments or the statements. The parentheses, brackets, and braces are used in mathematics and logic to eliminate ambiguity. In the language of symbolic logic also, those same punctuation marks, that is, parentheses, brackets, and braces, are equally essential because in logic, compound statements are themselves often compounded together into more complicated forms. So if I say P dot Q well R, what is it supposed to mean? It might mean that the conjunction of P with the disjunction of Q with R, or it may mean the disjunction of those first disjunct is the conjunction of P and Q and whose second disjunct is R. So in order to avoid such um, ambiguity, it is required to punctuate the symbols that the symbolic representation of the statements that we use in symbolic logic. The statement, I will study hard and pass the exam or fail, is ambiguous. It can mean I will study hard and pass the exam, or I will fail the exam, or I will study hard and I will either pass the exam or fail it. So the symbolic notification will be S.P F. If we simply symbolize it like this, that is, I will study hard will be S and pass the exam will be .P, or I will fail the exam will be well F. If we just write it like this, then the symbolic representation will also be ambiguous. So what we need to do is put parentheses and resolve the ambiguity. So in place of I will study hard and pass the exam, or I will fail the exam, we get S.P. That is, I will study hard and pass the exam, which is one disjunct. It is wholly forming one disjunct, or I will fail, which is the second disjunct. In this compound statement, you will see S dot P within parenthesis becomes one disjunct, and the next disjunct becomes just F. Or you can say, this is one way of writing the symbolizing the statement which is given. Or you can say, I will study hard and I will either pass the exam or fail it. You can also write it like this if you wish. So in that case, if that is what you want to express, then how will you put the punctuation, that is the brackets? You will write S dot within parenthesis P well F. In this case, S is the first conjunct and P well F is the second conjunct. So it is, I hope you can understand that just by putting the brackets in different places, in different groups, the entire meaning of the compound statement will change. Any mistake in doing this properly will make you commit some mistake, and your answer may be faulty. So be very careful when you are symbolizing the statements and putting them in brackets and parentheses. Now let's solve one question. This is question number 2, which is on page number 262, 8th edition, Introduction to Logic by Copi and Cohen. So using truth table definitions of the dot, the wedge, and the curl, determine which of the following statements are true. And the question is, not within brackets, London is the capital of England and Stockholm is the capital of Norway, bracket close. So in order to symbolize this, you can see that it is a conjunction and it consists of two conjuncts. So let the first conjunct be L. Why? Because London is there. Okay. And the second conjunct, let it be S, because to symbolize Stockholm. So, and there is a dot in between. So within brackets, you will write L dot S, and outside the bracket, you will put a negation mark, that is curl. That is not L dot S will be the correct symbolization of the given statement. Now, how to determine its truth value? In order to, whenever you're given a statement, first of all, you have to symbolize it. Symbolization should be easy by now. It is not that difficult, but don't get confused while solving the truth table. You have to be, it is not very difficult, but because you are going to you may need to make so many rows and columns, you might get you might make mistakes there, because it all consists of many T's and F's. So students make mistakes, just they tend to overlook. That is, it is not very difficult, but you have to be careful. You have to draw the truth table in a very neat and clean fashion, properly in a copy which is ruled, so that the T's and F's are completely aligned properly. Otherwise, you're bound to make some mistake. So you see in this compound statement, not L dot S. So how many variables are there? Variable means L, S, these are the variables. Let's understand this concept very simply to begin with. So since there are two variables, okay, two variables means if I write 2 to the power n, n is the number of variables. 2 to the power n, n is the number of variables. So I just now said there are two variables, L and S. So what will be 2 to the power n? It will be 2 to the power 2. Why 2? Because there are two variables, L and S. Now what is 2 to the power 2? 2 into 2, that is 4. Okay, which means there is going to be 4 rows of trues and false, T's and F's. 4 rows of T's and F's. This you have already done. This you have already seen in the previous truth tables of conjunction and disjunction. But when you will come across more variables, maybe 3, 4, 5, then you have to remember this formula, which is 2 to the power n. You will actually need this formula at that time. So you see, there has to be, first you put L in the first row, in the first column. In the second column, you write S. You are taking out the variables, the simple statements, the symbols for the simple statements one by one. So L, after L and S, what is the next thing? L dot S. You cannot straight away go to not L dot S. You have to first find out L dot S. From there you can find out the truth value of not L dot S. So you're going to make 4 columns, LS, L dot S and not L dot S. Making this truth table of L, S and L dot S will be extremely easy. It is just like the way you had learned when we came across the truth table for conjunction. So true, true is true, and all the other cases, the 3 remaining cases, when either L is false or S is false, L dot S is also false. So this is okay. This is how it is like it is supposed to be like this. This is the truth table for conjunction. But were we given L dot S? No, we were given the compounds statement not L dot S. So we put this not L dot S in the last column. So according to the rule of negation, you know, if L dot S is true, what will be not L dot S? Obviously false. Similarly, in the next row, if L dot L S is false, not L dot S will be true. Similarly, false will become true, false will become true. So you see the answer in this case will be false because the question, the statement, the compound statement that we were given is not L dot S, not L dot S, and if these are the conjuncts, the conjuncts are L and S. Come under L, you will see it is true. Come under S, again you will see it is true. Now come straight under not L dot S. You will see it is false. So this is very important. You have to remember when both these conjuncts, that is L and S are true and the conjunction is false, that is not L dot S is false, then the truth, this statement itself cannot be true. The truth value will be false. Do you understand? Because there is a not in front of L dot S, therefore the given statement will be false because it contradicts the rule the rule for the truth value of conjunction. This is question number 15. Not, not Stockholm is the capital of Norway. Well, Paris is the capital of France. Well, not London is the capital of England, and not Rome is the capital of Spain. So first symbolize the simple statements. Stockholm is the capital of Norway, will be S. Paris is the capital of France, let it be P. London is the capital of England, let it be L. Rome is the capital of Spain, let it be R. If so, then the compound statement can be symbolized as not, not S well P, well, not R dot not R, and then you have to remember to put the parentheses in proper places. Luckily, we don't have to put the parentheses ourselves. It is already given in the question. So when you are given a statement like this, how do you draw the truth table and how do you determine its truth value? So these are the steps. First, notice the number of variables. You will see the number of variables here is 4. Why? S, P, L and R. So the formula is L is 2 to the power n, where n is the number of variables. Here there are 4 variables. So 2 to the power 4 is 2 into 2 into 2 into 2. That is 16 lines or rows, whatever you wish to say. 16 lines of T's and F's you have to write in the proper order in order to work out the truth table. So if there are 16 lines, the first line, like I said before, divide 16 by 2. So the first 8 will be only trues, only T's, and the remaining 8 will only be F's. In the second situation, make half of that. That is 4, 4, 4, 4. First it is 8, 8. Then it is half of 8. That is 4, 4, 4, 4. In the third, it will be half of 4. That is 2, 2, 2, 2, 2, 2, 2, 2. And finally, it will be written alternatively. So line 1 will have half true and half false. Starting with true, you should always start with T, that is 8 plus 8 lines. Line 2 will have half of that, that is 4 true, 4 false, 4 true and 4 false. Line 3 will have half of the previous, that is 2 will be true alternating with 2 false, again 2 T's and 2 F's, 2 T's, 2 F's, 2 T's and 2 F's. And the last line will just be true, false, that is you have to write T and F alternatively. So this is the way you are going to write the truth table, the T's and the F's, before you start evaluating them. Now, what about the conjuncts and the disjuncts? How you're going to write? That is, what are the columns that you're going to make? The 16 is about the lines, that is the rows. What about the columns? Okay, so the easier method is to make separate columns for the variables first and then identify the small compound units so that it is easier to put the truth values under them. Then we can easily find the truth value of a conclusion or a given compound statement. The statement, the symbolized statement that you see here is the conclusion. We have to find out the truth value of this entire compound statement, and it comprises so many things. It comprises S, P, L, R. It comprises not S, well, P. It comprises not L, not R. It comprises not L dot not R. You see what I'm trying to say is each and every simple unit you have to identify, separate, and then put the truth value, and then only you will be able to solve the entire compound statement at one go. Otherwise, it is going to be very tricky. I mean, it may mislead you completely. So I've worked this out for you. It is, let's go to the next slide. We will see it there. Okay, so here is our symbolized compound statement. Not bracket, not within brackets S well P bracket close, well not bracket within brackets not L dot not R close all brackets. We are supposed to find out the truth value of this compound statement. You will see that I have made 12 columns. First of all, just write SPLR. Then, because these are the four variables. After that, we need, is there any not S there? No. So we need not put in not S. Is there SPLP? Is there any not P over here? No. So what are the nots? What are the negations we need? Only not L and not R. So column 6 is not L, and column 5th is not L, and column 6 is not R. Next we have this disjunct with us, which is S well P. But we also have not S well P. So in the 8th column, I have written not S well P. Again we have not L dot not R. You see, we have already taken out not L in column 5, and we have already taken out not R in column 6. So here we only have to take out the conjunction not L dot not R. In the 10th column, it is a negation of the column number 9, that is negation of not L dot not R. In the 11th column, we have not S well P, S well P, well not L dot not R. And in the 12th column, I have written the entire compound proposition whose truth value we are supposed to find out. Now coming to the rows, you will see that there are 16 rows. First 8 trues, T's and 8 F's. Then 4 T's and 4 F's. Likewise, you will do alternatively. In the third, you have true, true, false, false, like that, just half of the previous ones. And in the fourth line, you will see true, false, like that. It has to be written. So first, let's find out the truth value of this till column number 4. You're just writing it down mechanically as a rule. You are trying to find out the truth value from column number 5. where you have written not L. So if L, under L, it is true, then not L will be false. So wherever you will see L, just compare the L and not L. If L is true, then not L will be false. If L is false, then not L will be true. In this way, you're going to fill out the fifth column. Similarly, in the sixth column, we have not R. So wherever you have R as T, not R will be false. Wherever R is false, not R will be true. In this way, you are going to fill out the sixth column. In the seventh column, we have S will P. You already have S and P in the first and second column. So just remember the rule for disjunction. It is false, false is false. So compare column number 1 and 2. You will see that only in the last four, that is 13, 14, 15, 16, the disjunction, that is S will P, becomes false. Why? Because here both S and P are false. In all the other cases, if any one of the disjunct is true, then S will P will also be true. So in this way, you fill out the seventh column. The eighth column will be just the opposite of the seventh column. Why? Because eighth column is just the negation of column number 7. If S well P is true, not S well P will be false. In this way, you have to fill out all the 16 lines. Coming over to the ninth column. Here you have not L dot not R. We already have not L in column number 5, and we also have not R in column number 6. So according to the rule of conjunction, only when both the conjuncts are true, the conjunction will be true. And we have only a very few. Say, you will see in the fourth line, both not L and not R are true. Therefore, in column number 9, not L dot not R also becomes true. Again, we find in this is 8, line number 8, both not L and not R are true. Therefore, not L dot not R is also true. Again, we find in line number 12, true, true makes it true. And finally, the last one in line number 16, not L is true, not R is true. Therefore, in the ninth column, not L dot not R is also true. In this way, you are going to fill out the ninth column. In the 10th column is just the opposite of the ninth column. It is a negation of the ninth column. So if ninth was false, 10th will be true. So filling out the 10th column will be easier. You just write the negation of the ninth one. False becomes true and true becomes false. Now we come to the 11th column. In the 11th column, we have not S well P. Do you have not S well P anywhere? Yes, you have it in the 8th column. You will see that 8th column has not S well P. It is one disjunct of the 11th column. And in the 11th column, what is the other disjunct? The other disjunct is not L dot, not R, which is the 10th column. In 10th column, we have the second disjunct also. Now what we have to do is compare the two disjuncts. One is in column number 8, the other one is in column number 10. And according to the rule of disjunction for truth table, only when both the disjuncts are false, then the disjunction is false. So compare 8 and 10 and see in which line both 8 and 10 are false. So this is happening in line number, this is line number 8. Okay, so in line number 8, both 8 and 10 are false. Therefore, in the 8th line, 11th column, it is also false. Again, we find it is false in the 12th column, in the 12th column. So just fill out the false ones. You can you can just write T in all the other options. It is going to be true. Okay, only find out the false ones. The rest will be true, obviously. So now you have solved the compound statement. Almost 99% is done. The question that we have in the 12th column is nothing but a negation of the 11th column. Can you see that? The 12th column is nothing but a negation of the 11th column. So if 11th is true, 12th will be false. In all the cases, if 11th is true, 12th will be false. If 11th is false, then 12th will be true. So because it is the given compound statement is a negation of this disjunction, therefore in all the cases where the disjunction was true, the negation has been false. So the answer that you're going to get over here is false. So here is a brief recapitulation of what I just said. Column 11 is the compound statement, and the question is given in column 12, which is a negation of column 11, and the given compound statement is actually a disjunction. If you look at it carefully, it is actually a disjunction. Disjunction is the main logical connective here. One disjunct is not S well P, and the other disjunct is not L dot not R. So we had already separated the two disjuncts in column 8 and column 10. Comparing these two, comparing 8 and 10, we find that in column 11, the truth value of the compound disjunctive statement is in order and according to the rules. But column 12 negates that truth value. That is, compound statement is negated. Here, hence, the answer is not true. That is false. Okay, now let's consider these questions on page 264. You will see that while doing the symbolization, there are some common mistakes that we make. For example, consider these two statements, 4 and 5. Iran and Libya do not both raise the price of oil. Number 5, Iran and Libya both do not raise the price of oil. It is these sort of questions that we tend to make mistakes with. Remember, 4 and 5 will not be symbolized in the same way. You have to remember this trick. When you're coming across this word, do not, then after that, both. So when you're coming across the negation, do not both raise the price of oil, then put the negation sign first and then both, for both join them. If Iran is I and Libya is L, then first put a negation sign, then because there is both, that is conjunction, join I and L. So it becomes not within brackets I dot L. In the number five, it is Iran and Libya both do not raise the price of oil. Here both is written before and do not comes later on. Then the statement is structured like this. You're going to write both conjuncts have do not before them. That is, both do not. You see, both Iran and Libya, both, they do not. Both Iran and Libya have negation, that is, do not before them, and then they are conjoined. Remember it like this. So, not I dot not L. This is very, very important. It is a trick for you to remember. Just follow this trick and I hope it will help you during your exams. Okay, so let's move further. So till now we have discussed the sections 8.1 and 8.2, that is the general approach of modern symbolic logic and why it is needed. We have introduced and defined the symbols of curl, that is negation, and the truth functional connectives of conjunction, that is the dot, and disjunction, that is the wedge. We have also explained logical punctuation. We have understood how to draw and evaluate the truth value of compound statements. Uh, we have restricted ourselves to disjunction and conjunction in this video. So that is all that we have done till now. I have discussed only a couple of examples in this video from the exercises, but don't worry, you can access all the answers by clicking on the link given in the description box. So this brings us to the end of part 1 of chapter 8 Symbolic Logic video. In the next video, that is part 2 of chapter 8 Symbolic Logic, we will finish 8.3 and 8.4, that is conditional statements and material implication, argument forms and arguments. At the end of this video, I have to remind you once again that feel free to download the answers, solved papers in the PDF format that I have uploaded, and the link I have provided in the description box. So stay tuned. See you soon. Bye bye.